Hello everyone. So in this lecture we will be discussing about the subset sum problem. Now what does this problem say? This problem says that you are given an array n of positive integers and you are given a number x, again a positive integer. So what you need to do is you need to return a boolean in this case. And what does that boolean signify? The boolean signifies whether you can create a number x by summing up any of the subsets of the array n. So if we see an example, what do we see over here? We see an array of 4 positive integers 1, 2, 3, 4, and we are given a sum of 7. We need to find 7 out of all the subsets of 1, 2, 3, 4. So, and for sure by summing them, by summing the subset, summing the contents of the subset. Now the sum 7 is here represented with the help of x. So can I make 7 out of any of the subsets of 1, 2, 3, 4? Yes, I can make. Now the first subset would be 3, 4, which sums out to be 7. So I can return true, or I can also have a subset of 1, 2 and 4. I can sum of this subset or sum the contents of the subset and I will again get 7 over here. Now in the second example, I am given a sum of 10 or x equals 10. So can I make 10 out of any of the subset of 1, 2, 3, 4? Yes. If I sum up all the contents present within this array, then I can have a sum of 10. So I need to return true in this case as well. The third scenario or a third example we can take is that if we are given a sum of 12. Now can I make 12 out of any of the subsets of 1, 2, 3, 4? No, I cannot make it. So I need to return false in this case. So I highly recommend you to just pause the video over here, give this example a try, or because this problem is quite important. The algorithm which you will be following in this algorithm, in this question, so that would be used in quite a lot of problems in the upcoming lectures. So just give it a try because I would be starting with the explanation now. So now coming on to the explanation, what do I see over here is that I have some base cases and I have other case as well. So coming on to the base case, what does this base case states? This base case states that can I make a sum out of a given number or not? So if this is my x and x is represented by 7 minus array of current index is less than 0. So in this case it would be greater than 0. It's fine. But what if I put a 10 over here? Can I make 7 out of a number 10 or in this array? Can I make 7 out of this array? No, I cannot make it, because first of all, if I take the subsets, then how many subsets would I be having? I would be having again 2 subsets, one an empty set and one with a set containing 10. So can I make 7 out of this empty subset? No. Can I make 7 out of this 10? No. That's what it says over here. If the subtraction between this sum 7 and the array of current index, and in this case it would be 10, is less than 0, then I need to return false over there. In the second base case, what I can see is that if x minus current index leads to 0, so if this is the case, can I make 7 out of this array? Yes, I can make, because the first subset is an empty subset, the second subset would contain a 7. So if I just do 7 minus 7, so I would be having a 0. Hence I would be returning true in this case. What about if I just do this thing? Can I make 7 out of this array? No, again I cannot make it. Why? Because if I just take this element, if I just include this element, so what I would be having? I would be left with a 6. Then I would be proceeding in the array, but there is no element present in the array. So how can I make 6 over there? Hence my current index would be equal to size in this case, and I will be returning false. All these base cases would be quite clear when we just see the recursive tree over here. So coming on to the recursive tree, what do we see over here? We are given an array of 4 integers having contents of 1, 2, 3, 4, and I am asked that can I make 7 out of it or not? Now this is the function which will be returning true or false, this SS or subset sum. This is again a pointer or a reference to the array which we are having over here, 1, 2, 3, 4. This is the index, means, or the size of the elements, not index, actually it is the size of the elements. How many elements do we have in our array? This is the sum which we intend to make out of any of the subsets in this set, and this 0 signifies the current index where in this array where I am present at. Now if I just check how do I proceed with the algorithm, look, there are two ways for each and every element within the array. I can include it and I cannot include it. So if we see over here, now look, the brute force method which we are doing over here means I need to check for each and every subset. So how do I create subsets out of each and every subset, out of each and every set? Look, I am given 1 2 3 4. How many subsets do I have in this case? I would be having 16 subsets. Why? Because the number of subsets which I have are always 2 to the power n being the number of elements, and hence I would be trying to traverse each and every subset and just check whether can I make 7 out of it or not. I will be trying 1, then 1 2, then 1 2 3, then 1 2 3 4, then 2 3 2 4. I would be creating each and every subset, just check whether sum of that subset is equal to the x given or not, and if any one of that sum equals to 7, then I need to return true in that case. So that's what I am doing over here. I am trying to simulate to build each and every subset and check whether their sum is equal to the given number 7 or not. So in this case, what can I do with this one? There are only two options, whether to include this one into the current subset and whether not to include this element in the current subset. So how do I simulate this thing? I just recurse. And what do I recurse for? If I need to include this one into the subset, then I need to subtract this one from the current sum. So what am I having? The current sum is, I am having current sum as 7. So I would be recurring for array 4 6 1. What does the 6 signify? The 6 signifies that I have deducted a 1 from my current sum, and in the second branch what I would be doing, I wouldn't be including this one, and hence what would I be sending to the next recursive call? I would be sending the complete 7, but I would be incrementing my current index in both the cases. This increment means that look, I am done with my index 0 over here. So what do I need to recurse for? It says just tell me that from starting 1 to the end of the array, can I make 6 or not? The same way, what does this subproblem means? This subproblem means, okay, just tell me from this index 1 to the end of the array, just tell me, can I make 7 out of it or not? So the same way, if I just start branching over here as well, so how much do I need to make? I need to make 6, and currently I am at index 1. So again, there are two choices. I can include the element present at index 1, or else I would not. So what do? I just include it in the first path or in the first branch. So what is present at index 1? It is 2. So 6 minus 2 is 4. So what am I left with? How much sum do I need to make? It says that this subproblem says that look, I am currently at index 2. Just tell me that from starting at index 2 to the end of the array, can I create 4 or not? The same way, if I do not include 2, so what will I send? I will send the whole 6 over here. And this whole 6, what does this whole 6 signifies? This whole 6 signifies that I did not include the element present at index 1. Otherwise, if I would have included, then for sure I would have deducted something from it unless it would have been 0. But I only have positive integers. So if I send the whole sum down the recursive call, it means that I did not include that element. Hence, if I don't include this element present at 1, I would be sending whole sum down the path. Now I sent 6 over here. Now what does this subproblem say? This subproblem says just tell me from starting index 2 to the end of the array, can I have a subset sum of 6 or not? So coming on to this branch, what do we say? From starting index 2 to the end of the array, just tell me, can I have a subset sum of 4 or not? So again, at index 2, what I have a 3 over here. I need to branch out. In the first branch, I will include 3. In the second branch, I will not. So what I do? I include 3. If I include 3, I will subtract 3 from it. I will be left with only 1. Now what does this subproblem say? This subproblem says, look, starting from index 3 to the end of the array, just tell me, can I make 1 out of it or not? Or is any of the subsets lead a 1 or not? In the second branch, what am I asking? I am asking, look, I am left with a sum of 4 and just tell me whether from starting index 3 to the end of the array, can I make 4 or not? So if we just go in this branch, in our included branch where I included the element present at index 2, so what do I check? What I'm asking again, I'm asking that starting from index 3 to the end of the array, can I make 1 or not? So in the first branch, again, I will include the element present at index 3, and in the second branch, I will leave the element present at index 3. So if I include the element present at index 3, so what is the sum which I am left with? I am left with 1 minus array of index 3, and array of index 3 is 4. So 1 minus 4 is minus 3. So the problem, this last subproblem says that, look, I am left with only one element, which is 4, and I am left with a sum of 1. So can I make 1 out of this 4? So again, how do? I branch out. I branch out by including 4 in one scenario and by excluding 4 in another scenario. So what do I see over here? If I include 4 in this scenario, so what am I left with? I would be left with minus 3, because look, how do we used to include the element present at the index? We just used to deduct it from the leftover sum. So my leftover sum is 1 over here, because I am left with only 1 over here. So if I include the element present at index 3, so I need to deduct it from the leftover sum, and if I deduct it, then I am left with minus 3. And we hit our base case. This base case, it says that if I am left with a negative sum, so I should return false over there, because in no way I can create a negative sum out of the remaining elements. In this case, actually we are not even left with any of the elements, but if we would have even left with any of the elements, but we cannot create minus 3 out of it, because we again have only positive integers, and in no way by summing up some positive integers you will get a negative integer. So we need to return false over here. In the second branch, what do I see? I did not include 4 over here. That's why I just recursed for all the leftover sum. I just sent down the recursive call, the whole sum over here. I sent 1 and I just incremented my index. But what do I see over here? This index is out of bounds. So I have hit this base case. My current index is now greater than or equal to size. So, but I am still left over with the sum. So can I make 1 out of the remaining elements? And in this case, there is no remaining element. No, I cannot make any of the leftover sum with none of the elements. It is actually this base case. Can I make 1 out of any of the remaining elements? In our case, remaining elements are 0. No, I cannot make 1 out of 0 elements, and hence I will return false again. Now coming on to this branch, SS array 443, what does this mean? This says that, look, I am at index 3, just tell me from this starting index 3 to the end of the array, can I make 4 or not? So what do? Again, in the first branch I would be including the element present in index 3. In the second branch I would be excluding the element present in index 3. So if I include the element present in index 3, so what do? I just subtract it from the leftover sum. So 4, what does this signify? This signifies that I need to deduct it. It would be 4 minus array of 3. Now what is array of 3 in this case? It is 4. So can I replace this array of 3 as 4? So what am I left with? 4 minus 4, and it equals to 0. As soon as I recurse for array 404, what does this say? This say, look, that I am left with 0 sum. What does this 0 signify? This 0 signifies that I already got a subset which equals to 7. That's why I would have got a 0 over here. Otherwise I would have surely left with something else. And what does this 4 signify? This 4 signifies now I am out of bound. I have none of the elements left in the array. So whatever might be, but if I got my 0 in the leftover sum, it means that I I have already got a subset which equals to 7. So I would be returning true over here. So I will hit my this base case. What does this base case signify? That my remaining sum is equal to 0 and hence return true. In the second branch, I would be returning false again, because what am I left with? I did not include the element present in index 3. So I would be sending all of my sum down the recursive subcalls, recursive subproblems. So I would be sending 4 over here. I would be incrementing this index by 1 again. And what does this 4 signifies? This 4 signifies I am out of bound, I am none of the elements left, but I have none of the elements left, but I do have some leftover sum. So can I make a leftover sum out of none of the elements left? Again, can I make a sum, in this case 4, out of none of the elements left? No, I cannot do it. This subcall array ss array 444 signifies this thing. Can I make 4 out of an empty subset? No, I cannot make it. Hence I would be returning false, and we have hit our this base case. So what I would be doing, I would be taking OR of it. And what does this OR signifies? This OR signifies that what if I included this element and what if I did not include that element. In either of the cases, if I get a subset whose sum equals to 7, then I will return true over that. So now I will be returning true. So this subcall has a value of true. This subcall has a value of false again, because both of the cases or both of the branches had false. So false or true, it is, I would be returning true to this subcall. Now what does true signify to this subcall? The true signifies that out of starting from this index 2 till the end of the array, I got a subset which was equal to 4. That this true signifies this thing. Now again, this subcall would again be true over here, even if this subcall has a false or true. But even if I got true over here, then this subcall would be having a true. If this subcall has a true, so it's immaterial, but whatever I have over here, it will be returning true to my base call, and this base call would be having an answer as true. Now how did we get it true? This subcall has returned true. And what was this subcall? When I included the element present at index 0, that's why I reduced 7 to 6 when I included this one. So I included 1 over here. So what does this mean? That I included 1. I am just now calculating how did I get 7 and which subset led to 7. So, and in the two branches, which subcall led true to this subcall? This subcall, ss array 442. So, and when did I call this? When I included the element present at index 1. And what was that? It was 2. That's why I just reduced this 6 to 4, because I would have subtracted 2 from this 6. Hence, it is my leftover sum is now 4. So I included 2 over here. Now, how did I get true to this thing? I get true from this subcall. Look, because this subcall would have returned in false, because both of the base cases are false. So for sure, I would have got a true from this one. So, and how did I get this? By not included an element present at index 2. Because look, what I recursed for? I recursed for all of the leftover sum. That's why I have a 4 over here. So I did not include 3, and hence I would not be including 3 to this subset. Now, which subcall led this subcall to be true? This subcall, array 404. And what is this subcall? This subcall means that I included the element present at index 3, and hence I got a 0 over here. Because if I would have included the element present at index 3, which is 4, I would have deducted that from the leftover sum, and what would I be left with? I would have left with 0, and hence this subcall returned true to me. So I included 4 to it, plus 4. So which subset gave me answer to 7, and which led this to be true? In this recursive tree, this is not again the complete recursive tree. You need to recurse for all other subsets as well. This is one of the subset. So the subset of 1, 2, 4 led to an answer of 7, or sum of a 7. Now I just wanna tell you what about this subset. What was this subset which returned false? This subset was including 1, including 2, including 3, and including 4. 1 plus 2 plus 3 plus 4. This is this subset. Again, what is this subset? I included 1, I again included 2, but I didn't include 3, but I included 4. So 4 plus 2, 6, 6 plus 1, 7. Wait a minute. No, I did something wrong. I included 1 in this case. I did include 2 over here. I did include 3 as well, but yes, I didn't include 4. This false is with the subset 1, 2, 3. Okay, and what about this subset? This subset states that I included a 1, I included 2, I didn't include 3, but I included 4. So sorry, I didn't include 4 as well. That's why I'm left over with 4 over here. So this subset states 1, 2. So the same way you would be creating all these subsets, and then you would be checking that, okay, which of these subsets sum up to the intended sum, and hence you would be returning true if any of the subset would be equal to the intended sum. So what would be the complexity of this? So the complexity of generating all the subsets of a given array would be 2 to the power n. So in the next lecture we will be discussing that how to bring down this complexity from this exponential to polynomial time.